That's coming.
Okay. He had the time, right?
Okay. Thank you very much for well, fixing your laptop. And now for the final speaker of the day, please give a round of applause for Dragan.
Thank you. Sorry for this. I guess it's about trying to run Linux kernel mode on Windows. It's actually Windows preview version, so I assume it's that. Yeah. Yep. So, is it working? Yep. Okay, let's finally start. So, my name is Dragan Gajic. I'm coming from Levi 9, from our delivery center in Serbia. And basically, we start to look at microservices end of 2014. So, back then I was architect, so I was actively participating in that. And we did 2 projects where I was involved, heavily involved. So I wanted to share some experience with you. Now after almost a year and a half. So it's I did this kind of presentation on one of the conferences, and well, it's a buzzword, you know. So and everybody was talking about that. So and what's actually the promise of microservice? So if you want to do it, this is how you kind of rationalize that to your management, because you know it's kind of thing you would like to do it anyhow, regardless of the, you know, is it good or not. But basically this is how you will explain it. So maintainability, because if you have really big app, then it's hard to maintain. There are a lot of dependencies, so if you change something, you can break something else, and so forth and so on. Continuous deployment with a large app can be difficult. You have all those running processes in the background. The whole process of deploying can be slow, which affects downtime and these kind of things. So it sounds logical that if you have small pieces and you can deploy them independently, that will work better. Scalability, well, I think that one is easy. Because if you want to scale out the one big monolithic app, you scale all the parts of it, and you know not all parts of the application are used at the same frequency. So if you look any website, any app, some of the functionalities are used more frequently than others. So if you kind of divide that into microservices, then you can scale out only those parts which need to be scaled. Well, availability, that's a interesting one, because in monolithic app, everything is connected within the same process. If something breaks, it can break the whole system. With microservices, it's isolated. So if you kind of have a good mechanism to handle failures of each microservices, you should be good. So basically, if one fails, the application still continues to work if you did it right. With microservices, you can mix technologies. So we didn't do that, but it's possible. So basically, you can do one service in Python, the other one in Java, in Scala. If you inherit something, this is how you can wrap them, and not developing everything from scratch. And being now a manager, I'm also looking at how you can manage a team which is greater than 7, 8, 9 people. That's hard if they are all working on the same code base, because the ownership with developers starts with ownership of the code. So if you have people working on the same code repository, then you need to think about the processes, branching model, these kind of things. If you kind of separate that, then it's easier to manage. So these are all good reasons why to go to microservices, but we all know that that actually functioning like that, so that it's not kind of silver bullet. And what's the issue? Well, effectively, we are talking about distributed systems, and with distributed systems, you have all these kind of issues. So, configuration management. So you don't configure one app, you configure multiple. The communication between services. So with a monolithic app, you can still have components, but they run within the same process. And they communicate really easy because they are in the same process. If you put them in separate processes, you need to handle communication between them. Service discovery. So if you want to scale out per service, what happens, who balance that load to another instance, these kind of things. You need to orchestrate them, because for sure you'll have functionalities which spans out multiple services. Testing is harder, because if you want to do end-to-end testing, then you need to do the complete flow. Distributed transactions, they are hard by nature. And here, if you have transaction which spans more than one microservice, and you want to treat it as transaction, then we are talking about distributed transaction, and that's hard. Versioning, another one, interesting. So, what do you do then? Well, you go for frameworks, for tools to help you to solve these kind of issues, because distributed systems, this is not something new. It has been there for more than 20 years. So the problems are defined, explained, kind of solved. So what we used to develop these two apps, and I will describe them, how they are different. It's basically Java. We like Spring, so we use everything from Spring. So we have like 10 years of experience using Spring, even from version 1.2. So, and they have of course, in a big portfolio of projects. I think it's more than 60 projects now. The new one is actually Spring Cloud. I'll tell something about that. And Spring Boot is kind of Spring vision, how to pack everything into single running unit. So, and of course, for the configuration management, Ansible Puppet. So we use both. Of course, Docker, you cannot have a speech not mentioning containers these days, so it's there. Console for configuration management, and also service discovery tool. This is what we use. And on one project we use Jenkins, on another one we use Bamboo, simply because the other one was completely on Atlassian, so naturally we use the stack there. Typically, long time ago we used Hudson, if somebody recalls that. So Jenkins in the past used to be one project, Hudson, and then it splitted. And now we are moving all that in cloud, Bamboo, on-premise, because Atlassian will not do it anymore in the cloud. They had a model where agents are actually running on AVS, apparently, which is a smart model, because compiling, building can consume a lot of resources. But apparently, end of this year, I think, they will not do it anymore. So we are moving that on-premise now. Couple of words of Spring Cloud. I put this picture to show how it's positioned. Actually, they wrap it and abstracted a lot of things Netflix produced. Netflix is one of the pioneers in this area, and guys from Spring are doing things in a way that if they see something is good, they abstract it, and then you can use multiple things. So from Netflix, you have their Hystrix, which is circuit breaker. You have Ribbon, which is kind of client-side load balancing, Feign, which is declarative HTTP client, and many other things. So they wrap it, you can put it to your Spring Boot application, then it will use class path scanning to figure out how to configure the app. If you didn't take a look, my advice is also to go to 12-factor app. There is a website explaining some of the basic principles how to build cloud and microservice ready apps. And they say there each microservice should be in separate code repository, don't mix them. You need to have a different build pipeline for each of them so you can deliver them independently, these kind of things. And of course Spring Boot, which is something these days we use for all of the apps. So typically we don't talk about servlet containers, application servers for microservices. Maybe for some bigger app, but for small apps, Spring Boot is totally fine. So I said we did 2 big projects, more than a year. So I put them main characteristic here. First one is the greenfield, perfect one. So you don't have a legacy. You can practically do whatever you want within the boundaries you agreed. So that's nice. Characteristic of this solution, it's multi-tenant app. So basically for each customer you need to bring, because of the security in these kind of things, they are very strict, separate tenant. Should be flexible. Branding, all that stuff is in there. It's mission critical. It's built on top of REST APIs, how you build it now. We kind of decided on this one to try containers within the hybrid model. What's hybrid model? So basically the application stack is wrapped into the containers. So at the end of our pipeline, we don't produce Spring Boot jar or var. We produce Docker container. And that's only for application stack. The rest, persistence, Mongo, that's kind of provisioned or configured via Ansible. This is why I call it hybrid solution. And this stuff runs within the DC data center. So it's not AVS because of the privacy issues. So the second app is probably something you will find more often in practice. Existing system built as monolithic one, a lot of legacy code. You want to move it to microservice. Why would you like to do that? Well, basically it's too big. You need to put a lot of people to work. You don't want to talk about release trains, release procedures, sign off, these kind of things. You want to be more agile. Of course, typically with that system, usually there is relational database, which is pretty important. You always have, because in past like 10, 15 years, or maybe even 20, this is the way you were building apps. So you have your data store, your relational database, part of business logic there, and then you build application around it. So there are a lot of third-party dependencies. Since stuff with databases, and if you have existing system, it's not easy. We also said, okay, so we need to refactor database. So huge. If you start to do that now, it will take year and a half. So let's do in 2 phases. First, let's shield database with REST APIs. Let's move business logic to the APIs. Reconnect all the apps who are accessing database directly to APIs. And then we can start to think about refactoring database. So this is the approach we took here. We also use Spring Boot, Puppet, because I have some IT guys who really like Puppet. So, and we didn't have any kind of, let's say, influence from the client side here. So we use that one. And with this system, originally, it runs in dedicated data center, but there are a lot of constraints. So we are currently moving to AVS. When I say constraints, so they have these load balancers which we don't have access. It's not easy to change anything. So you need to put a ticket. When you put ticket, you need to wait, and these kind of things with the ELB, that will be much faster. So these are two cases. How they are different? Well, basically, one is a greenfield. You can do, there is no legacy, so basically you don't have constraints. You have risks if you want to do new stuff, but basically no legacy. With another one, which I believe is more typical, central relational database, a lot of stuff there, and then some legacy code. So you want gradually to move to microservices. I isolated, let's say, 4 interesting things for me, but afterwards you can ask, because there are plenty of things you need to think of when you do this. So I'll try to, for each of these things, to say how it went in both cases. So first one is data store. I deliberately call it data store because even 10 years ago I was not really thrilled with those domain model generators. With the Hibernate you had a stuff which connects to database and generate all your domain classes. So for me the data persistence data store was only that, just to store some data in a reliable way. So of course you can query, but if you do public websites or high load websites, usually you need to put some indexing, some more smart, faster ways on top of relational database. So I tend still to look at it as a data store. So with this greenfield project it was easy. Domain model is not that complex. It's what I call profile centric. So we use Mongo there, because Mongo is document-based store. If you have one main entity there, everything connected, then it's perfect for that. As I said, for that other app, we decided not to touch database. First phase is build APIs on top of it. The problem is, like, you can build microservices, but if they still connect to the single point, they are your dependencies, and that's the issue. You basically kind of, like a previous speaker said, you fake it. You have microservices, but the ownership starts with the data ownership. So they say that each microservice should be exclusive owner of the data, because then you avoid the things with the dependencies, with locking, all kind of stuff. Of course, different microservices can have different storage requirements. One opt just for a simple document store like Mongo. The other one needs more advanced search functionalities. Then you can use Solar or Elasticsearch or any kind of, if you're working with a lot of relations, you can put graph database. So, and this, what I'm saying makes sense, but it's not easy. Why? Because entities are interconnected. So how to do a cut, that's not easy. So typically what you will see, that you can do table, schema, or database per microservice. In case of database per microservice, you can even use different type of the store. Of course, the end goal is to have loose coupling. What's hard? Distributed transactions again. If you have different stores, it's really hard to do it. You can do two-phase commit, but if your engine is not supporting these kind of things, it's really hard. So the best is don't do it. If you need to do it, then maybe this is not the best example of the app you will transfer to microservice. Joins, because each service returns single portion of data, maybe your representation requires more, and these kind of things. And of course, if you have multiple stores, you need still to operate them in production, so more effort. Security, well, with a monolithic app, it's easy. It's running within the single process. You authenticate once. It's easy to share that. With microservices, it's not easy to share. So what you want to do is that you have single identity authenticated only once. So you don't want, that's must. So the second principle, I believe, is which is important, authorization is done locally on the level of microservice. Why? Microservices are organized around functionalities and kind of who can do what. It's a business rule. So it should be within the microservice, not on the API gateway or on some other level, because this way you kind of again create dependencies. So microservice itself should know what to do with this user. And the way you can transfer the information about the user, well, typically you do OAuth2, which is kind of delegation protocol. So you authenticate once, push some access code to the user, but internally you can pack roles, permissions into JVT token and use it internally. This way you can pass that information to each microservice. You don't need to access to your user store to get that information. It's signed, so you know who is accessing. So this is the stuff we build. So basically, access token externally, short-living, internally JSON web tokens, because you can pack information in it. And then each microservice can consume that information. Short on inter-service communication, that's interesting because we have different components within different processes, even different languages. So typically you can divide the communication to synchronous and asynchronous. Synchronous will be typically HTTP, REST APIs. So what's interesting there, discussion whether you will do client-side load balancing or you will go through the common router. So client load balancing, it's kind of cool to do it. But to be honest, we have more than 40 projects, 40 clients. I know just one who actually needs that. Client-side load balancing is more performant because if you go always through proxy, there is one additional network round trip. So you really need to have application which can profit from it. As I said, I know just one where that is justified. If you have centralized routing, you can do blue-green deployments more easy because you can do it on that level. If you kind of do client-side load balancing, it's harder because each microservice can decide to which one to push the request. And we had interesting discussion when we started this Greenfield project because we kind of use Java on each microservice. And then you basically have microservice A calls microservice B. It's the same object. And there was discussion, should we create some kind of common model, common domain model? No, because then you create dependency. So, and within the Spring Cloud, there is, they call that declarative client, which is called Feign, where you can, with some annotation, describe what from the JSON you need. You don't need the code, it's just interface. So the introspection will do the rest for you. And don't repeat yourself. Principle, I would say, not that important anymore. So why you will not, I would rather avoid creating dependencies. So if I need one class from the JSON, 3 fields, I will create it here. 5 fields here, I will not inherit. I will copy 3 and add 2, and then I will avoid to create dependency. If you create dependencies, whoever changed this affects both microservices. This is what you want to avoid. For asynchronous, we typically use RabbitMQ. And from my experience, that acts as a, I will not say enterprise service bus, but as a common bus where you push events. And then you can use publish subscribe. So don't use it for anything else. For communication, use REST APIs. Within the Spring Cloud, you have a retry mechanism, all these kind of things. Hystrix with circuit breaker. Events and long-running processes should go to the queue. And monitoring. This is actually from the live systems. So we use a lot of monitoring tools. We build them from the start. And typically, you need to push a lot of metrics from your app. Access logs are there. So we use ELK stack, we use Logstash. We push that to Elasticsearch. This is from Kibana. You can get average response time per every node, a lot of things you can get just from access logs. If you have a lot of data, we use SQS, AVS SQS. It has some limits. So we are now looking into Kafka for distributed messaging. So if you have a lot of nodes, a lot of logs, and you want to do it via Logstash, you can do it all kind of different ways. We kind of put it in the queue and then feed Elasticsearch. You can also do it through Kafka. So these two, I don't know, do you use application performance monitoring tools? They are great, especially if you go live. These are kind of production capable profilers. So they do snapshots. There are two of them which are well known. They cover a lot of languages, technologies. One is AppDynamics. The second one is New Relic. You can run them on premise. You can run them in the cloud. They are expensive, but they are really good. Because with the monitoring tool, if you monitor average response time, what typically you monitor? Load, number of requests, average response time, number of errors. If that's okay, probably the system is okay. If that is not okay, you need to dig in. With these kind of tools, you can see what's not okay. You know. So, and you can do the similar stuff because these kind of tools can connect business transactions. There is also a project from Spring called Spring Sleuth, which can add stuff to your business transactions so you can connect it if it is passes boundaries of one microservice. So you know it's the same business transaction. Okay. Conclusions. Maintainability. Yeah, it is improved. It's smaller code base, but it's harder to run the system. Why? Because idea that you can work, especially if you start the project, then you have the core team. Because to get your APIs right is not easy. When you start with it, you still need to run the whole system. Then we use tools like Docker Compose or Docker Swarm now to run the whole system on your laptop, because especially testers need that because they do end-to-end tests. So at the end you need to try. So contracts are fine, but at the end you need to try. Or you can go for Vagrant. Continuous deployment, what I really see that we miss is kernel releasing green-blue deployments, these kind of stuff. So this is something we'll work on. So we are not yet there with it. Feature toggling, this is something we really need. So we didn't manage to deal with it. These other things, I think they are okay. For the governance, managing the teams, well, there is an issue with the people. If people are used to do things in a certain way, it's hard to change that. So don't underestimate that. This is what we also saw. Typically, you do application in layers. If you need to switch to the APIs and API first approach, it takes some time. So don't underestimate, although it might sound everything logical, you should do it that. It's not easy. What I see for the future. So we are currently investigating all this. They call that container orchestration platforms. There are 3 of them: Kubernetes, Mesos, and Docker Swarm, which is kind of new. Why that? Well, if you pack everything into container, I don't want really to code configuration management. So I don't want to code high availability. I don't want to code routing. I don't want to code these basic principles. I would like to have a platform which provides that to me. This is how I see these tools. We are currently, we define like 10 criteria and try to compare them We have 5 internal systems, different languages, different platforms. We want to pack them into containers and run on this kind of platform. It's a kind of hybrid cloud, but for me it's also being developer and in starting as an IT ops guy, it's really important to know the clear boundary, because what I experience, if you do kind of Ansible Puppet, you need to get guys together, and you know developers are pushing constantly new stuff. So you know you create Puppet module for Tomcat, and then we add Rabbit MQ, then we want 0 MQ, and they don't have it. There is no such thing on Puppet Forge. It's kind of, you are coding that I would like to avoid. So this we will take a look, and at the end, if that is too risky for you, there is one great open source project just started. It's called VAMP, very awesome microservice project. It's actually a startup from the Netherlands. So they build basically canary releasing platform with dynamic router, all kind of stuff. And for provisioning, they use Kubernetes, Mesos, or Docker Swarm. So they integrate with everything. We know the guy. Guy is really, he's from Amsterdam. So he's really willing to help and support. And this is something I would also like to try, because I feel these kind of things, especially for you guys, I think, you know, if you have one feature, you know what's kind of releasing. So if you have one new feature, you can push that feature to production, and then on your router, you can say all users from internal network or all users from Netherlands will see that new feature. So this tool actually allows you to do that, and it nicely integrates with all these container orchestration platforms. So this is something we didn't manage to try in past year and a half. I'm especially interested in these 3, and also currently releasing also to try it, how it works for our customers. That's all. Questions?
Cool. I think the container guys and the Red Hat guys also want to be on the final slide. Any questions for Dragan? Otherwise, I have to make one up. No one? Oh, okay, then you're stuck with a question from me. Oh!
Can you go into the stuff that comes from the Spring Cloud from Netflix? So you said you're using the circuit breaker, but what are the other stuff you're using?
Ribbon. Ribbon is a client-side load balancer. So basically...
But you said you're having trouble with your load balancer.
No. I didn't said we had troubles. I said I think with the new Docker Swarm, there is a better way with the routing mesh. So what's the thing? So there is a Eureka. Eureka is a service discovery service from Netflix. So these guys from Spring Cloud kind of wrap it.
And you're using that with console?
No, you can use either that or console, but they put a layer of abstraction, so you just put appropriate dependency, and it will work with console or with Eureka. So on one project we use Spring Config Server and Eureka. Spring Config Server is good because it can store configuration on Git, for example, encrypted. And Eureka is something coming from Netflix. On other project with the same code, we use console because there is stronger IT ops community which likes things from HashiCorp. So, but basically on the level of the code, it's the same, just one annotation, and Spring Boot app will contact service discovery, and Ribbon will do client-side load balancing. You can also configure retries. So if the call fails, it can retry 3 times, and you can, with the histories, you can define also circuit breaker, how to handle that. So, and we started with a Spring Cloud when it was a milestone. So I was not looking for a couple of months. They had an awful lot of new stuff there. So it's one of the that is also base for Cloud Foundry, which is a platform as a service stuff from Pivotal. So if you build application with a Spring Cloud, it will be also ready for the Cloud Foundry.
Other question? Okay. Why go for like these weak-typed microservices instead of going for like an actor framework like Akka, for instance? Because then everything is nicely, strongly typed. You also have the scaling. You also have some of the abstractions.
Yeah.
You can build like the distributed transactions much more easily. It's much faster.
But if you put
It's like binary transport instead of this
I agree.
freaking text stuff, which then you
Or
also have
if-
to do over SSL.
I agree.
This is horrible.
But
This is like back to the Stone Age.
yeah. But if you want to put like 50 people on the project with your stuff, they will be still on the same code base, right?
Yeah.
Well, that's an issue. How to manage team of 50 people. If you have a huge system,
We
so
just saw a great talk about refactoring and like how easy that is, and like automated tests when I hit save.
yeah. So yeah, I agree with you. But scalability is not really. So I know that people, when they talk about microservices on the conferences, they always demonstrate auto scaling. So I understand from where your question is coming, but it's not
Then with like
Yeah.
something like Akka, you scale
Yeah.
the whole bunch instead of just
exactly.
one role.
So you can do it differently, but basically I think microservices, the main thing is you group them, organize them around functionalities. So if you have a really big system, then you can put 50 people and effectively manage them.
Yeah, but still, you can just start from one code base, and then it's like really easy to take out this part and really abstract it with a hard HTTP boundary.
Yeah, but then you end with microservices. If they are running within the same
Yeah,
process.
so I think my point is it's much easier to start with, and then also
if you
grow your
opt,
project. To
if you opt for scaling, that's fine. If you have like 15,000 concurrent users per second, but these systems are rare. If you are building ad serving platform, I agree. But if you are building business app, which typically has like up to 1,000 calls per minute, why do you need Akka then?
no, but then the whole microservices thing is a vanity thing.
Netflix and Amazon exist on microservice, and you do not get bigger systems than either of those two.
Yeah.
So if you're looking at like, will this scale to large systems? Netflix is a third of internet traffic. Like that is a ridiculous amount of the internet.
Yeah. So if you're not Amazon, you should maybe stick to a simpler solution.
You're saying that it scales better, but I mean like microservices scale, like performance-wise.
No, it's just simpler. It probably the upper bound
No,
is,
the thing
is
I-
much
with the-
higher.
Let's go to a bar.
Now the thing with Akka comes with this kind of things out of the box. So there is no scaling without scaling across different machines, right?
Sure.
So yeah, if you opt for scaling, I agree. You can use Akka. We use the Akka, but this story is about something else actually. So
okay.
you can apply that. Would you use Akka for the business app?
I think it's better to have the strong typed interfaces instead of all these weak type ones.
No, but how, framework is doing that for you. But for example, if you want to change the version, these kind of things, it's one code base. That's the difference. So, but if you kind of have Python service which is doing fine, you don't want to change it. There are APIs. If there are no APIs, you will find a way to integrate. Then you will build the rest in this. So we had a rare opportunity to do greenfield project, but most of the work, you guys know, it's kind of, this is the stuff. It's so big now. How we'll kind of change it, not break anything else? That's a typical problem in IT. And I'm looking at the microservices more on that than on scaling, because scaling you can do that stuff. It's stateless, so messaging, other kind of things, non-blocking IOs, Vertex. There are plenty of things if you want to do scaling. But I'm talking about business apps, the stuff most of IT is running. Although your examples are good, but I don't think there are exceptions. I really think there are exceptions. This, yeah.
But let's take Jelmer's cue on that and discuss that over beers at the bar. There's a bar in this building in Sanomatalo, which is called Painobari. So for the people that still want to join us for beer, let's go there. Please all thank Dragan for his talk. The next episode is December 12th in Hoofddorp. The next one here in Helsinki. Well, might be in February of next year. So thank you all for coming and thank you all for watching. Until next time then.
Thank you.